Hi, I'm Nina Zakharenko. Some of you might follow me on Twitter at NNJA, and I'm here today to show you how to light up your life with Python and LEDs. Who am I? I work at Microsoft as a Python developer advocate, and I focus on making Azure and VS Code better to use for Python developers everywhere. I've written software for over a decade at companies like Meetup, Reddit, and HBO. My background is in software, but I've been working on hardware as a hobby for the past few years. If you want to reach out, please follow me on Twitter at NNJA or Twitch at NNJAIO. And I'm also happy to share that I'm a newly elected board member of the Python Software Foundation. Now, I want to tell you that software doesn't have to be serious. I used to have a lot of creative energy when I was younger and an interest in computers from a young age. I thought I gave up on all of that when I joined the workforce, or nobody would take me seriously as a developer. I feel like my first few jobs really sucked the creativity out of me. I was working for some large enterprises and financial institutions, and my opportunities for creative coding really faded away. I slowly built that back up by working on open source. Tinkering with hardware was what really let my creativity explode. And it's taken me a few years to reconnect with that part of myself and relearn the lesson that I learned all of those years ago, that software doesn't have to be serious. You can use code to make art like this. This is a Python version of a processing sketch by Saskia Freak. And hardware doesn't have to be serious either. This is Simone Giertz. She's an incredible maker and queen of robots, and she makes very, very silly contraptions. This is one of my own creations, and it is inspired by a project by Sophie Wong. It's an LED jacket, but I made a version that I can control with Bluetooth, so I can change the colors of the LEDs with my phone, because making something like this was really fun for me. It let me create a physical manifestation of my code. I really love the idea of LEDs, of making cool wearable projects, and I wanted to make pretty things that fit my own aesthetic, which is what got me interested in hardware in the first place. And I've really been inspired by amazing shared projects and docs from other makers like Becky Stern and Sophie Wong. And I made this jacket with LEDs. I programmed it in CircuitPython. And I'm really not an expert in electronics. I never studied it in school, and you don't have to be either to make projects like this. Okay, so Python on hardware. Earlier I mentioned you might have heard of Arduino code, which is a C++ variant, which unfortunately it's not very easy to learn. It's very error prone. We as a community know from experience that Python is the opposite. It's easy to learn, it's beginner friendly, and it's great for education. In fact, it was announced in January of last year that Python was going to be the official programming language for high school education in France. And how do we go about programming Python on hardware? At the moment, we have two options. We have MicroPython and CircuitPython. MicroPython is a variant of Python 3 that is optimized to run on microcontrollers. It's very compact. It's what runs on the microbit. CircuitPython is an education-friendly fork of MicroPython that is maintained by Adafruit. I'm going to be showing you demos on Adafruit hardware, and so we're going to be using CircuitPython today. These are a few other devices that run Python. The BBC Microbit, which is a computing device aimed at learning that runs MicroPython. There's the Adafruit M0 and M4 that runs CircuitPython. And then the Raspberry Pi Zero W, which is a small development kit with wireless and Bluetooth capabilities, runs Python as well. Depending on where you purchased your hardware, it might come with Python installed by default, it might not. I'm going to be showing you a device that I really like that is focused on education called the Adafruit Circuit Playground Express. It's, I think, a great option for an introduction to electronics and programming hardware. And as a learning platform, the cost, at least in the US, is only about $25. Now, Python has this batteries included philosophy. There's PEP 206 that says the Python source distribution has maintained a philosophy of batteries included, which means having a rich and versatile standard library which is immediately available without making the user download separate packages. I think that this has helped drive Python's success. Now, the Circuit Playground Express that I'm going to show you doesn't actually come with batteries, but I imagine that the same philosophy applies. It has everything that you need to get started programming with hardware included on one board. So just a quick tour of what's on it. There are 10 NeoPixel RGB LEDs. Each one can display 16 million colors. There is a light sensor, temperature sensor, some programmable buttons on the left and the right, a switch, an accelerometer to detect motion. There's a micro USB jack, which makes it easy to program. And best of all, there is no soldering required to access these features, which is great for kids or for clumsy adults. And you can easily connect other things to it with alligator clips. You can even sew on it with conductive thread. Now, I'm going to be showing you some live demos from my desk today. I actually have a Circuit Playground Express with me. So this is the one that is on my desk, and I have it right here, and I'll be showing you some demos shortly. Okay, so we talked about the LEDs. How do we light up the LEDs that are on the front of this device? Well, there's an important concept that you need to know about RGB LEDs. An RGB LED is really a combination of 3 tiny LEDs in just one package. RGB stands for red, green, and blue. And if you look at the color wheel on the right-hand side, you can see that you can produce almost any color by combining these 3 colors in intensities varying from 0 to 255. Now, 0 means that the color is not present. For example, blue is set to 255, red set to 0, and green set to 0 would produce pure blue. By combining the intensities of these colors, you can produce 16 million color variations. Now, I didn't fully understand this until I found this picture of an RGB LED in action under a microscope. So let's take a quick look at that. Here's the tiny RGB LED. There are 3 LEDs present in each one of these, red, green, and blue. And these 3 tiny LEDs can light up one by one, or all together, or a combination, but because they're so small, your eye actually sees them as one color. In this picture, the initial picture, they are all off. Here's a photo with just one LED on. This is the red LED. And you can tell the color that is going to appear by the color of the outside ring. So in this case, it is red. Here is just the green LED that is lit, and just the blue LED that's lit. When all of them are turned on, the LED is going to look white to your eye. And depending on the combinations of colors, it can look like all the different colors in between. Know that NeoPixel is the Adafruit brand name for an individually addressable LED that's commonly known as the WS2812. Now, how do we program it? This is a lot easier than working with Arduino-based platforms. If you've worked with Arduino in the past, you have to unplug and reset the board, and it's kind of tedious. With CircuitPython, you can just plug in the device with a data and charge USB cable, and you'll see a CircuitPython drive on Mac. It will be in volumes CircuitPy. If you don't see it there, you can install CircuitPython on the device. Once you have done that, you can create or edit a code.py file in the root directory. And every time you save it, it's going to get automatically reloaded to the device. So it's a really quick and easy workflow. Now, I like programming with Visual Studio Code and the Python extension, which is what I'm going to be showing you today. But what you really need to know is you can use any editor that you like, but you need to use an editor that writes out the file completely when you save it. And there are other really good options available for programming hardware in Python. If you're more of a beginner or you're less familiar with Python, the Mu editor is a great option. Now, what happens if you don't have the hardware? Adafruit is based in New York. For a while earlier this year, they weren't shipping. Maybe this hardware is difficult to get in Korea. Well, some interns at Microsoft released a really cool project called the Device Simulator Express extension. So you can use this to simulate a few platforms like the Microbit, the Circuit Playground Express, and even the Adafruit Clueboard. And I'm going to be showing you a short demo of this today. And there's a link in the slides to download the extension that's available here. If you want to take a look at the slides, they're at nina.2/PyKR2020. One more option for programming these boards, if you want to get started programming hardware with zero coding and without the device itself, there's something called Microsoft MakeCode. It's a block-based editor. You can export it as JavaScript. There's some really cool collaborations like the Cartoon Network, and you don't need to have the hardware. It's an emulator. You can see what's happening right away. And I think this drag and drop interface is really simple to understand for kids or for folks who might not necessarily be familiar with programming. It can make them productive very quickly. So let's take a look at some simple code that's for the Circuit Playground Express. First, we import the library as CPX. Next, we make a color variable for red. Remember RGB. So I'm setting 255 for the red position, 0 for the green position, 0 for the blue position. And I'm also setting the brightness down because otherwise by default it's very bright. Now, we want to keep looping forever, not just running our code once. You want to think of it as an animation. If you just run it once, your LED would blink red and then it would turn off right away. So if you want to keep the red color on, you need to loop forever. And we're using a cpx.pixels.fill helper method to fill all the pixels on the board with one color. Now, this library also exposes some of the different components on this board. So in this case, we have button A and button B that's on the board. We can access them with cpx.button_A and cpx.button_B. And those variables will be set to true when the button is pressed and false when it's not. Okay, so let's take a look at this code in the VS Code emulator, or VS Code Device Simulator Express. So I would need to open my VS Code command palette, and since I already have the Device Simulator Express extension installed, you would have to go ahead and install that first. And then when we go to our code, I can open my command palette and say Device Simulator Express run simulator. And it'll show us a little diagram of the Circuit Playground Express here on the right-hand side. So if we look at this code, we'll see that if we press button A, the pixels should fill with red. So let's try that. If we hover the mouse over here, we'll see that button A is highlighted. So when we press button A, the pixels are filled with red. Otherwise, if we press button B, the pixels are filled with the color blue. If neither of the buttons are pressed, then we don't fill the LEDs with anything. We just keep them off, which is pretty cool. Now, let's look at some code that's a little bit more complicated. Here's a simple program that's going to cycle through red, green, and blue with button presses. And let's walk through this one by one. So first, I'm importing the two libraries that I'm using, the Circuit Playground Express library and Time. And I'm setting up some colors that I'm going to be using in my code, red, green, and blue. Again, notice where the 0 and the 255s are. Then I'm going to make a list of all the colors that I want to loop through, starting at a position of 0. Again, instead of running our code once, and so it doesn't stop after the first time, we're going to loop forever. And we're going to constantly be checking for input. So I'm going to be filling the LEDs on the Circuit Playground Express with the selected color. And then if button A or button B is pressed, I'm going to flip over to the next color. And then I'm going to sleep for just 1/5 of a second to prevent multiple button presses. So let's take a look at what this looks like. Now for this demo, I'm going to close the simulator because I'm going to be showing you on the actual device simulator, on the actual Circuit Playground Express that is on my desktop right here. So taking a look at this, I'll see that I have a Circuit PY folder, and I'm going to open code.py, which is what is currently running on this device. So as you'll see, the LEDs are red. Now if I press a button, it should switch to green, and then it should switch to blue. Red, green, blue, each time I press the button. Doesn't matter which button I press. Let's change our code a little bit. Let's take a look at our color chart. And let's add a new color to this list. For this example, I want to pick yellow, which is a mix of red and green. So I'm going to make a new variable, yellow. Remember, I'm going to set 255 for red, 255 for green, and 0 for blue to make yellow. And then I'm going to add yellow to my list. Now that I have saved, my code should be on this device already automatically. I don't have to do anything special. So let's test it out and see if it works. I'm switching over to green, switching over to blue, and now one more button press, and now I have yellow. So the code to make this was pretty straightforward. Okay, so I'm not the only one that thinks hardware is really cool. 90% of students said that the microbit showed them that anyone can code. 86% of surveyed students said the microbit made computer science more interesting. But something that's near and dear to me is that 70% more girls surveyed said they would choose computing as a school subject after using the microbit. There was a study called Unlocking the Clubhouse that suggested that traditional computing culture is a boys' club and it's unfriendly to women, and we need to find ways to unlock this clubhouse to make it accessible. There was a study on e-textiles called Lily Pad in the Wild, which suggested a different approach called building new clubhouses. Instead of trying to fit people into existing engineering cultures, it may be more constructive to try to spark and support new cultures, to build new clubhouses, and make room for more diverse interests and passions. And remember that diversity doesn't stop at gender. We want to use Python on hardware to encourage everyone to participate. People of different ethnicities and socioeconomic status, identities, neurodiversity, age, and many other factors. So let's make Python on hardware the most diverse community that we can. Now, the hardware community is really awesome about sharing incredible projects with step-by-step instructions. Some of the places that you might find these is Adafruit Guides, Microsoft Make Code, or Instructables. On the left is a jack-o'-lantern project where you only need the Circuit Playground board and a Ziploc bag if you opt for a real pumpkin. Python on hardware is still relatively new, so don't forget to share your own projects. And Angela Sheehan is a maker that I really look up to. She created these incredible LED high heel shoes and a lot more. So just one more example of making new clubhouses. How cool are these? And the nature of hardware is being able to see these instantaneous results. More importantly, being able to customize your projects helps you connect to them from the start. It helps make technology more accessible to those who are traditionally underrepresented in it. This picture of girls with huge beaming smiles is one of my favorites. It is they're made by girls participants that made LEDs light up in masks. So e-textiles, Sobel electronics, paper crafts, these all help to introduce technology in new and unexpected ways. Now, I'm wearing one of my favorite projects on camera. This is based on a different Adafruit Python board, the Gemma M0 and some LED rings. And it's based on an original design by Becky Stern. Let's see if I can get these to turn on. So my earrings that are on right now run Python, which I absolutely love. You can check out the code on GitHub if you would like. And I wanted to say that you've seen that Python opens up this whole new world of working with hardware. And Lawrence Durrell said that our inventions mirror our secret wishes. So hopefully this inspires you to try it out on your own. Next steps for you, if you have access to a Circuit Playground Express, that's a great first start. If you don't, you can still learn about the concepts of hardware with Microsoft MakeCode, with the Device Simulator Express. And I hope that I've shown you that you don't necessarily need to be an expert or know a lot about electronics to just get started. And please write your code, but also share it with the community, follow a community guide, and learn, make things great, and teach others. It's a really fantastic cycle that we can all participate in. If you want to share your projects, you can use the Python hardware hashtag on Twitter to get started. And thank you all so much. It's really been my pleasure being able to speak to PyCon Korea remotely this year. I hope that I've left you inspired and that you've learned how to program LEDs with Python to light up your own life with code and creativity. The slides will be posted at the link here, nina.2/PyKR2020. And thank you all so much.